Okay, I think we're live. Hello everyone, my name is Clifford Agius. Hopefully you can see me. If someone puts something in the chat so that I know that it's happening. Actually, I see Richard, you've put, is it happening? Hopefully you can see me now. My name is Clifford Agius. I'm here to talk about 3D printed Bionic Hand and a mobile app and some IoT along the way. Firstly, a bit of housekeeping. If I get onto the right thing, welcome to Developer. It's an awesome conference and it's free, which is great, and it's happening this year. I didn't think it was going to happen, but squeeze one in December. Bit of thing about the conference and making sure our code of conduct. I'm sure you've seen this in the other talks and you'll see it again later today. But let's just be friendly, be nice, and if you have any questions, you can follow the link in the bottom right there to report anything you see that you don't like. Moving on, note, we are supporting the National Museum of Computing. They need all the help they can get, so if you can, go out to their website and help donate, buy some t-shirts or some swag stuff on them. Be a fantastic way of supporting them, and even better, grab your family and go visit them. It's an awesome place, and we're trying to support them and help them. Our sponsors today, I'm not going to go through them. You can see them all there. There's quite a few of them, yeah, it's quite. I'm just looking at and seeing the whole Q&A whizzing along. Make it social. Let's tweet about it. Let's make this bigger. If not now, then for the next one as well. So you got the tweet handles there. So you can reach out, and if you want to get me, I'm at Clifford Agius, and you can see that on the side of my slides all the time. But what are we here to talk about today? Well, a little bit about me. I'm an airline pilot for a major UK airline. When I'm not doing that, I'm a freelance .NET Xamarin IOT developer. So that's a bit about me. I love code. I love developing. I was an engineer in the automotive industry for 11 plus years before taking up flying. I'll come back to and talk about why I mentioned flying and being an airline pilot a little bit later on. But as you can see there, that's a 787 flight deck. I'm off next week to Dallas, and so I'll get to fly the Dreamliner, the Dash 10, the new one, up to Dallas next week. But meet Caden. We're here to talk about Caden. Now, Caden, as you can see here, is a happy-go-lucky teenager. He's family friends. We're friends with his family, and we know him and his sisters quite well with my children as well. But you notice there in the upper picture that Caden's missing his left forearm, and on his right hand he's missing his fingers, his middle fingers. So he's just got a main finger and a thumb. But he's happy-go-lucky. He's active in the Scouts. And he's quite a fun child and teenager. They do exist, apparently. He's one of them. You can see here he's off to the London 2012 Olympics. You can see here he's given a prosthetic arm by the NHS National Health Service here in the UK. And you can see that's his party trick. He clicks it onto something and steps away so that his stump pulls out the end of the prosthetic arm. And everyone's shocked. Oh, he's just pulled his arm off. You can see there he's quite young. That was 2012, and he has a formed plastic arm, and then on the end is the hook. That hook moves to the next arm, and as he's gotten older, he's moved up. That was the last one he had that was a formed plastic. Now moved to the fiberglass because he's getting a bit older. You can see in the bottom photo there. There's the red one is the one he got after the plastic one, and then he moved on to the green one. I have the red one here. You can see the hook on the end. Now these cost the NHS anywhere between £4,500 and £6,000 to make. That's the arm without the hook. Now the hook on the end costs between £1,500 and £2,500. So these are not cheap items for the NHS National Health Service. So we need to kind of think about ways of making this cheaper, not just for the health service, but making it cheaper for other children around the world that do not have the fantastic health service that we have here in the UK, or maybe other Western countries that you're watching this from. So back in 2016, this appeared on the news. I took my boys to school, bumped into Sharon, which is Caden's mum, in school playground, and she said, "Have you seen the news, Cliff, about this this dad that's 3D printed a I don't know what one drives, getting in the way, 3D printed an arm for his daughter?" And I hadn't shown, no. And she went, "Well, you've got 3D printers, haven't you, Cliff? Any chance you can have a look and help?" It's like, well, why not? I like a challenge. Let's give it a go. So what can we do? Hold my beer. Well, first thing we do is we obviously go out to the internet and start Googling or Bingling or whatever it is you choose, Ask Jeeves maybe. And I started looking around the National Health Service and tracking down through the links that Sharon told me about, come across the Limitless Association, the families I remember. And I looked and it said useful links. So I come here, and this has been here. I've been giving this talk for over 2 years now. This page has been under construction for over 2 years. So the developers doing quite well out of that project. If they're on a day rate, they're doing fantastic. But not much help. So again, looking around, looking at the websites for the BBC, Sky News, etc., and found out that Enabling the Future, the team Unlimited was the team that were behind that news story. So we come across this website's obviously changed quite a bit. But I printed off the arm that was then. It wasn't Isabella. I can't remember the name off the top of my head at the moment, what it was called. But I printed the hand out, and we had this hand here. Please let me know if you can see my my screen as well. But printed out this hand here, which clicked into the end of Caden's arm, and we tried it out. He hated it because it doesn't close up, so he can't grip things very well, and he wasn't very keen. So we then decided, well, that's not going to work. So we went back to the drawing board after printing that and trying that. I come across the Open Hand project. Now, this is by a gentleman called Joel Gibbard. And Joel was doing this as a university project, and looking at bionic hands, and putting motors and servos inside 3D printed parts. And he come across. I've just seen. In fact, thank you, Richard. In fact, you can see me. He built this project and made them quite well. So I started looking into this. He then, shortly after I kind of started paying attention, come across and made a company called Open Bionics. And you see here, a fantastic company, and they make these 3D printed prosthetic arms that they now sell. But at the time, Open Bionics, it's in the name, it was open, and they had a GitHub project where you could go along and download the 3D STL files and send them to the 3D printer to print. Now these, as you can see here, they're the last time they were edited 2, 3, 4 years ago, so they're quite old now. Now, I believe what's happened, I've not managed to speak to the team, sent them emails, they've not replied, but it seems to me that what's happened is that as they've gone to try and get approvals to selling these around the world, France, Germany, the USA, even trying to get them into the NHS in the UK, they've had to comply with certain regulations because it's a medical prosthetic, and in doing so they've had to go closed source rather than open source. But it's fine, they've left the files there, which is nice because it's still on GitHub for us to take and use and build out our project. So this is Caden with his hook. You can see here, I visited him to chat through the project, and he's making me a nice cup of tea. But you can see here, he's got his arm. You can see that he has a strap going across his back. He normally has it under his shirt, but he's worn it above for us to see in this video. And he goes to his shoulder on his other, a pad on his other shoulder. And as he moves that pad back to the boards, it pulls on the strap and pulls the claw open and closed. It's quite a simple solution. That work won't be as well now. But it's quite a simple solution of how to get the claw to open and close, and it's literally elastic bands that they borrowed from the postman to get it to work. It's a fantastic cup of tea. So we fired up the printer and we started printing the first bits of the Brunel, which is what Open Bionics call their 3D printed hands. And as you can see there, it didn't come out very well on my original my Mendel printer, which I've still got up on my shelf up the top there. It's retired now. The quality wasn't very good, so as good developers obviously would go out and buy the latest and greatest new one. So I bought this Mark III. It's since been upgraded to Mark III S. This is a fantastic printer. It's about £700 now. I bought it in about 900, so it was a fair bit more expensive. When I bought it, the price has dropped considerably now. You can see there, I've ringed a bit in blue. Now, all the bits that you can see that are in black plastic there, they're all 3D printed in the Prusa factory. I broke that part that's in blue when I was building my printer, so I've fired up the old Mendel, and it got one last final hurrah print, and it printed that that bit in blue, and it's still in blue on the printer at the moment. And so, you know, the old printer lives on in the new one, so it carried forward. So we got all the parts printed, as you can see here. All the parts in white are printed in PLA, and that's like a hardware in plastic, a bit like Lego. The bits you can see in red, that's a flexible filament plastic, so that's quite flexible and bendy. And then you've got all the components that we ordered off the internet. You have to buy them in fairly large bulk items, like 1,000 of the brass inserts, but you only need about 10. So you have to buy them in pretty kind of bulk items. And then you have the 4 motors, or linear motors down there. You apply them a DC voltage, and the piston moves out by 20 mil. Apply DC voltage in on the other direction, and it moves back in 20 mil. And you can stop it at any point in between, and it's got an inbuilt potentiometer, so it can tell you where the motor is in its position. So we have all these components. Now we need to connect it to Caden. Obviously, we need a socket, because we don't want to stick it in the hook on the end, because that's the expensive part, is the arm. So we designed a socket. We took the socket that he got from Roehampton Hospital, which is where he's looked after by the fantastic medics there. And we took a 3D scan and copy, and we printed it. So you can see here, you can see that there's 5 hours 45 minutes left remaining of the print. It's quite late in the evening, so I went off to bed. Come back in the morning to the spaghetti monster that is seen by many 3D printers around the world. And basically what happened is the part popped off the print bed, and it carried on printing in thin air. So we ended up with that spaghetti monster. But thankfully, as you can see in the middle image, it's printed enough for us to test. So we took that to Caden, we tried it on, and it's too small. So we printed another one, you can see here, and that was too big. So in nursery rhyme style, the third one was just right. So you can see there was 5 hours and 2 minutes left remaining on that one. That one came out perfect. Version 3, and it fitted Caden like a glove, to the point where he said it actually fitted better than the one that the NHS provide, which he has to every year go back to the hospital to get recast, resized, wait a couple of weeks and make a new one, and then he gets that sent out to him and fitted. That component there, that plastic that he's wearing, costs 80 pence to print. It takes about 8 hours to print, so 80 pence of plastic, and he's got a new socket. So every few months, Caden comes to me, says, Cliff, it doesn't fit, so we print a new one for 80 pence. So this is where we're kind of actually getting to the fact that we can bring this down to prices that actually work for us. So we look at the component prices. You can see the top, the molds is the top section comes to £9.46. You can see in here £9.46. That is for the molds that are used, like this mold here. And if I show you Handy, you can see Handy has got this this black neoprene rubber, which is here, which is allow them to grip things. Otherwise, you know, Lego's quite slippery, and you can't really it won't grip things very well. So this is cast in a mold. These molds I've got here, I've made probably sort of 15, 16 hands now, and I'm using the same set of molds. So that £10 is, you know, you make it once and you just carry on using it. The hand parts you can see in the middle come to £5, £4.93 makes all the hand parts. 80 pence for the sockets, and another, I think it was 94 pence for the centre part of the arm, this section here. And so, you know, for less than £6 or £7, we've got a complete prosthetic arm, completely 3D printed. You got the ligaments at the bottom, which are the red bits I showed you earlier on. They come to 20 pence. Yes, you do have to buy fairly expensive spool of filament for that. So the flexible part you can see is £28.37 when I put this slide together for the spool of filament. But that's for a kilo, and we're using kind of, you know, 7 grams. So you can see that 1 kilo will last for a really long time if you treat it well and keep it dry. What about the control? So now we have the 3D printed parts. How do we control this arm? Well, Open Bionics at the time had the chestnut board. The designs are still on GitHub. You can go and download them, and you can get a fab shop to make you one. Quite expensive though. single source supplier. At the time, they had a store, and you could go on as a developer and buy components from them. Now they've gone closed source and they're selling the arms to people around the world. They no longer sell the components. Whether they sell them if you buy an arm, I don't know. But this board was quite expensive. I think it must seem to remember being £250 plus postage plus VAT, etc., etc. So it wasn't a cheap board, and I waited for a couple of months for them to come in stock. They never come in stock, so I couldn't get one. So how does that board get its signals from Caden then? Well, it uses these myaware sensors. Now these sensors are muscle sensors. You can buy them. They're about £35 each. You need two. Got one just here, and they stick on your muscle, and they measure the electrical signals that pass through us as human beings, and provide those as a analog signal which goes into the control board to supply a signal. But how does that work? Well, let's look a little bit more into how this EMG signal works. You need to place them correctly. These boards cost £35 each. We need two of them, and we're sticking them on a child. Now, if we go back one, you can see the pads. Now, if you've ever had an ECG with a doctor, or medic when you go into hospital, maybe for an operation, they stick the pads all over, don't you? And they hurt when they peel them off because it pulls the hairs with them. These pads need to be changed. There's 3 required for each of the boards. You need 2 boards. You need 6 per day. Every day you need to change them. So another 6, another 6, another 6. That's the expense going forward. But you also need to place them correctly on a child, and then it's stuck to the skin. So these boards are quite expensive, £35 each, and they could get broken by the child. Children are children, they break things. But you also need to place them absolutely correctly. You can see here the example of a muscle, and the only one that works is the green one in the center. So even slightly off to the right or a little bit higher up the muscle group, and you won't get a signal that's worth using. Not to scale, but obviously you need to stick it on a muscle. You need to get it correct. But you need one on the inside of the forearm and one on the outside of the forearm. Now, why do I say this? Well, if we look at this, if you hold your arm up like I'm doing here, and you pinch the fingers and you put them at the bottom of your, just above your elbow, either side of your hand. If you do the open signal, like you can see in the right of the image, you'll feel the muscle at the back of your elbow go tight. If you do the close signal, you'll feel the muscle at the front go tight. So now you've got an open and close to open and close grip. What if we want to go to the next grip? If you create a fist, both muscles go tight. So now we can open the grip, close the grip, and we can get Caden or the other child to create a fist, and both muscles go tight. You hold that for a second or two, and then we can switch to the next grip in the grip sequence. So now we can go around a grip sequence. So we've got control. So this is quite an ingenious idea, both in Bionics, but the implementation wasn't ideal in my mind. So now we've got different grips that we can do. So we can program the electronics with different grips. Open Bionics, the Beetroot software that they originally launched had 5 grips contained within it. Fist, palm grip, carrying the shopping bags. Caden asked me to remove that. He doesn't want to help with the shopping. But OK grip, or to tripod to hold a pencil, point gesture, so it's over there. But these grips are great, but maybe the child wants another grip. Caden wanted one so he could play his Xbox, for example. And you go around that grip. Like I was saying, you grip your fist to make a fist to go to the next grip in the grip sequence. If you miss that, you've got to go around the sequence again. But what if you wanted to add a new grip? Us as developers, we can fire up Visual Studio or VS Code and work on the code and work out how to make it work. But let me show you how it works. This here is the, it should expand, great. This here is the 3D array that's inside the code. If we look at the palm grip, you can see on the left-hand side, it starts at 0 and 1, and 0 to 100, and all that is an animation timer. So over the course of, I think in Caden's arm at the moment, it's set to 1.8 seconds. Over the course of 1.8 seconds, it runs across that array, counts up from 0 to 100. And as it gets to a number that matches, it goes across and sets the finger positions to that position. So if we look further down here to the pinch grip, when it gets to 10, it starts moving F0, which is the thumb, to the 700 position. And the positions, the fingers are 0 to 1024, so it moves it to 700, which is 3/4 of the way. And then as it gets to 100, because the thumb is almost there, it can move that last bit and the fingers fold over the top of it, and that creates the pinch grip. So it's quite simple for us as developers. You know, I've explained it to you. I'm pretty certain you could go away and within 15-20 minutes come up with a new 3D array, new element to put in this array that you could program to make an Xbox grip, for example. But what about the medics at the hospital? What about the family at home? What about the child themselves? They're not going to be able to do this unless they've got a laptop or computer with Visual Studio, VS Code. They've learned how to program in, you know, this is Arduino C. They know they've got the cables, they've got to take the hand apart to plug the cable into the embedded electronics. It's not ideal. And again, so I made a little list of drawbacks while I was waiting for this project. As we all do, we make little issues lists, maybe on GitHub, of things we don't like. So the open source Bionic board, single source supplier, often out of stock. They've now closed the store, you can't get them, and it's expensive. Mireware sensors. One thing I didn't mention earlier is the fact that the sensors, the muscle's weak because Caden wasn't using it. And as the muscle gains in strength when you're using it, you get a jeweler screwdriver and just change the gain levels inside to set the gain levels again. So the signal coming out is a level you can read, and it's not clipping at the top. Expensive boards. You need the pads, 6 per day. For £5, you can buy 50 of them off eBay. But again, it's, you know, quite expensive, ongoing costs maybe for people around the world that can't afford this sort of thing. And then we talked about the personal grips at the bottom. So let's try and tackle some of these problems. First one was the board. I use a lot of Adafruit and Arduino boards in projects, IoT projects I do for clients. And this Adafruit M0 Bluefruit is a fantastic board. It's exactly the same process on the Open Bionics board. So it's I can literally load the software in and change a few settings in there, and it works perfectly. But on the bottom there, that red part at the bottom down here, you can see is a Bluetooth tool, Bluetooth transmitter receiver, which allows the board to communicate with Bluetooth devices. That means I can now, like I mentioned earlier, I work with Xamarin. I can now work with a mobile app. So got some of these boards, literally ordered them off of Amazon, and I wanted to prove the point I could get these boards from anywhere and cheaply. And this arrived, and it cost, I think, £28, delivered to my door the next day by the postman. Specs on it, like I say, it's the same processor, 3.3 volt logic, so the power was quite simple to get from a LiPo battery, a LiPo backup. We had enough analog pins and PWM, which is pulse width modulation, controlling the motors, but no EEPROM, as you can see, the fourth line down. That come back to bite me a little bit later. We managed to solve that, but they call it a feather system because they say it's light as a feather. It's 6 grams, so when that board is sitting in the back of the hands, it's not got a massive weight moment that's going to make Caden struggle to hold his arm on. What we did was we took the boards, rather than using PWM to control the motors, because that was just going to be a bit messy, we offloaded that control to Adafruit. Had their feather system that has a remote controller board, which is the one where you can see the red and black wires spooling away. That board, I think, was £18 or £19. I can't remember now. Not expensive at all, and we wired that together. So now what we do is we talk to that board with I2C, which is a serial communications protocol that's used in IoT systems. And so the main board with Bluetooth tells the motor controller board, send motor 1 to this position, and it just sorts it out for you and manages the signal for you and does it all. And you can see on the right hand side, the initial problem had the motor controller board is the fact that the motors the electronic motors that fit in the back of the hand have a flat ribbon cable, and we need to get that to work with a through hole board. Took some months, but eventually found a connector that managed to connect that flat ribbon cable that's the correct size that we could then solder to quite happily without needing some specialist tools and equipment, because I wanted to make this whole project such that anyone doesn't need the skills that I've got and been trained in my engineering career in fine soldering skills. I want to be this so that you can download this from GitHub and build it at home yourself. You can see the connectors at the bottom managed to get, and a bit of ribbon cable, and then we've got some components there. That Polyloo board, The motors use 12 volts DC to control themselves. And you heard me mention earlier that we use 3.3 volts for the controller board. One of the things as well that the Open Bionics arm uses is it uses a big battery that sits in the back of the arm. And that battery is similar to what you put in a radio controlled car, 14.7 volts. It's a big, hefty battery, and you need a special power supply to charge it. I wanted to get away with that, so I had, just like we all do, the Anchor battery packs or the power bricks that we get from our favourite conferences as giveaways. I wanted to get away from that, so I took a 5-volt Anchor power brick, USB, so you can charge it within the USB socket, and that hollow board steps up to 12 volts. That 12 volts feeds the motors. There's another one that's on the back of the board which steps the 5 volts down to 3.3 volts, which feeds into the two control boards. So those boards are not very expensive. They're less than £10 each. So now I'm taking a 20,000 milliamp hour battery from Anchor, which is bought off Amazon. Again, next day delivery for about 20 or 30 quid. And that is now powering the boards. So again, we're getting all these components down to off-the-shelf, easy to obtain parts. So we've crossed off the processors, so we're good there. Now back to the malware sensors. I was flying across to Japan in the middle of Russian airspace, trucking along, fat, dumb and happy, and I read this magazine called Hackspace. It's a wonderful magazine and all about IOT components and parts. And they had a bit about Arduino debugging. You notice the sensor that is plugged into the board down here. This is a piezoelectric sensor, a bit like the buzzer that's in your PC that buzzes, when you turn it on and you've got a big old desktop. We all remember the big old desktop buzzers in our PC. This works the other way. This one, you apply a pressure and it gives you a voltage. A piezoelectric buzzer, apply a voltage and it vibrates. This one, it detects vibration and gives a voltage out. Very, very cheap. I bought 10 of these for £1 from Amazon, delivered next day to my house. I waited till I got home and we tried them out and they worked brilliantly. But the problem was that Caden could no longer eat, because you can only sense a vibration, a knock. It can only detect the fact that it's been bashed and give you a signal. So then we was using that to send the hand fully closed or fully open. But the old way of using the malware, Caden could stop the hand mid position just by stopping the muscle sensor from detecting. So he didn't like it as much as the malware sensors. So okay, we'll go back to the drawing board. We'll see what we can do. We're on to something here. And then Sparkfun Electronics, another website I use a lot for buying components. They had this full sensitive resistor on sale, and I see this, and as you can see there in the GIF, as you apply pressure, the voltage out. It's basically a resistor. The voltage difference across the resistor changes as the more pressure you apply. So these were fantastic. You can see the price there, £6 each. We ended up using a slightly bigger one, a rectangular one, which I think was about £5 each, as opposed to £6 for a pack of two. And that was just purely so that it covered more of the muscle group in Caden's arm. So then we come up with our joint. This is a fits-in joint. It looks a bit messy, but trust me, it's a very, very simple circuit to build. It takes about an hour for me to solder it all together, if not a bit shorter, and all the components on that image there. So now we've crossed off the malware sensors because we don't need those the sticky pads anymore. This just sits inside Caden's arm. It just sits inside the socket. They're glued inside the socket. And he just slots it on and off he goes, much like what Open Bionics is using now. They're using some higher-end sensors that are very, very expensive haptic feedback sensors as well, so inside their arms now. So now on to the last bit, the grip sequence. We're on to the how we're going to change the grip sequence and allow people to control this. So this is, I'm thinking, the medics, the doctors in the hospital, the parents at home if it's a younger child. Caden himself, he's 16 years old now. He wants to be able to set his grips up himself and control them. And it's not just putting a new grip in, it's also controlling the grips. Like I said earlier, we had 5 grips in that grip sequence. We want Caden to be able to, so maybe he's gone to school and he only wants 2 grips, so he can quickly change between the 2. Maybe he's at home and he doesn't want the grips that he uses at school. He doesn't want to hold a pencil at home. He doesn't want that one. He wants his Xbox grip and maybe hold a fork grip so he can eat his dinner. Maybe he wants to reorder them. The order he wants them will be different from another child. So he wants to put them in a different order. So we looked at the Bluetooth. We've got Bluetooth on board on Handy. If you've ever played with Bluetooth, it's an absolute minefield of acronyms and different versions. You've got low energy and smart, and it's chaotic. I thought I knew a bit about Bluetooth when I started this project. It turns out I knew next to nothing. I'm now barely dangerous with it, because even now, having spent a couple of years playing with it, it's still a minefield of things going on. But I'm going to quickly give you a primer. As you know, a Bluetooth device, you have a central device like your mobile phone, but your mobile phone can talk to lots of peripherals, maybe the headset, because you're listening to a wonderful podcast, or it's your car, because you just jumped into your car and it's connected to your stereo, and it's connected to your car's system, so you can speak to it to phone mum, that sort of thing. So that's how it works. And the way it works with Bluetooth Low Energy is it's a bit blurry, actually. I'm not sure if I think it's because I've changed the screen resolution. This slide seems to have gone blurry. Apologies for that. But the way it works is when the connection is established between the master and slave device, and apologies that it says master and slave, but this is what it's still called in the Bluetooth world. But the connection, when they establish a connection, they agree a timing when they will talk to each other. And you can set that in the software, and then the master says that I will speak to you every 100 milliseconds. I'll connect you. So master sends a request, slave sends a response, and in that communication, and then they go to sleep. And this is not very well shown in this slide. I think I'm going to redraw this slide actually and change it about a bit. But and then they go to sleep for a while, and that's where you get your low energy, because now they're not communicating. And then they wake up again 100 milliseconds later and do their communication. Inside that communication is a packet that's sent, and it's much like a class with properties inside. So you've got your profile, your servicing characteristics. Just think like that as a normal .NET class with your properties inside, and a service could be a method inside that as well. So you can go in there. I've got a Bluetooth Garmin watch here. In that would be the Garmin watch would be the profile. In that would be a service which is the heart rate monitor. And in that would be the characteristic of what's my current heart rate, which has been my resting heart rate. That's the kind of things you can get out of your Bluetooth devices. So I wanted to go across to, I had a lot of trouble getting this running earlier, connecting to the system. There we go. It's down here, because Teams was not playing last for me. So inside the Adafruit board, which is quite small, it's quite simple. We changed and added the Bluetooth control inside the board. So Adafruit, wonderful team across there in New York. They provide the Bluetooth libraries, and they give you the parts you need. Now, inside the Handy, when it was made by Bionic, they had the ability for you to plug a cable in the side of the hand, and you can control the hand with commands from the command shell. So you can send it commands over a serial port using something like PuTTY, or the Arduino software has a serial monitor in there. You can send it commands like A3 turns the motors on and off. So all you wanted to do was, rather than reinvent the wheel, we just wanted to send those commands backwards and forwards and keep the commands as were. So inside we put in the Bluetooth libraries, and this is all in Arduino C. We set a minimum firmware version because we needed to make sure that the communications was such that it worked with the Bluetooth boards, but also it works with the mobile app as well. We give the device a name. I call it Handy. So when you look on the device, it appears as you open your Bluetooth on your phone and search the device, it will come up with, I don't know, your TV, your car, your Garmin watch. So we've called it Handy. We allow that to be changed in the app now. And then all we do is we set a flag. We tell it to start begin the connection, and this print.begin is just a library that's inside the Arduino Adafruit library that's provided. We do a factory reset. This is more for development because I'm constantly tinkering around in the settings. So we do a factory reset, so we know we're back to a normal basic board. We turn off the echo, and that's because every time it sends a command, it echoes it back. We don't need that. It's a waste of energy. And then we wait for the Bluetooth to connect. So we just wait for 5 seconds for that to connect. If it doesn't connect, even in the first 5 seconds, the board turns off the Bluetooth because it's not detecting the phone. And then that just saves battery instead of sending Bluetooth connections. It also makes sure that someone else doesn't jump on that Bluetooth connection with their phone. They've downloaded the app and they're controlling Caden or another child's hand. So Caden just needs to reboot his arm and connect within that first 5 seconds for it to work. And then once we're connected, and then we can send some commands across and enable the Bluetooth. And then all we do is we poll that Bluetooth every time it comes around the loop within the Arduino and read in from the buffer, the data, and we can send commands out. So we can print, and it's just like, debug.println or console.writeline. We just do Bluetooth print, and we print out a string, a value, a string array, whatever it is we need to do. I've just basically rewritten those so that it goes out over Bluetooth and works. It's as simple as that. Where's my slides gone again? There we go. So now we've got the Bluetooth working, and we was testing that with Adafruit. Even have an app you can download from the App Store where it's literally a UART, which is a serial protocol, and you can just send serial strings backwards and forwards to the boards. And I've got it working. We could control that. Now we need to make our own app for working with this arm and handy. Like I said earlier, I do a lot of Xamarin development as well. I'm quite active in the community there, so it was an easy choice for me. But I wanted to make sure that it fitted the bill. It needs to work on all platforms. I own an Android device. Caden has an Android device. His parents both have iPhones. The next child could have an Android device. Someone could have, a Windows tablet because they don't have a mobile phone. Maybe the doctors and medics in the hospital have a Windows machine. So we need to work on UWP as well for that. We need to access the Bluetooth stack. That's native within Xamarin. You can access that. I'm a C#.NET developer. I prefer working in C# than working in Java and the like. So I wanted it to be that as well. But more importantly, we wanted to have accessibility built in. When it's such that, and Caden, he has the buttons slightly bigger because he's got less digits to push them with. So we needed to make it such that when he uses his Android phone, and in that he has accessibility settings such that text is bigger, the buttons are bigger, etc., etc. That works for him. So he can change that at OS level, and the app works with it and makes it work for him. Xamarin does all that for you because essentially when you publish your Xamarin app, it compiles down to a native app that runs on the device. So obviously chose Xamarin. A little about Xamarin, if you've not used it, you've got Xamarin Traditional, which is where you used to write the C#, which back end, which is all your service layer, your business layer, your models, etc., etc. And then the UI you wrote in the Objective-C or Android XAML, UWP, etc., which is fine. Great, but you're writing the UI layer 3 times. You need to kind of think about the storyboards on iOS, etc., etc. Or you got Xamarin Forms, which is where the UI layer is written in XAML or C#. You can write in C# as well. I prefer writing in XAML. I don't know why my head likes to split, UI in XAML, and maybe that's because websites and HTML and stuff in the past, and then the C# the back end. And that works, and it compiles that UI layer down such that it looks the same on each of the devices. But if you put a button, the button will appear on iOS like a normal native iOS button, as they do on Android, a normal native Android button that you know and love if you've got either of those platforms. So we now go across and look at the where's it gone? The app. In Xamarin Forms, there's a Xamarin Forms shell, which is a way of abstracting away all the navigation stack that's within Xamarin Forms. It used to be quite a pain, and you see loads of boilerplate code needs to be written just to do the navigation between the pages. because each of the different platforms, iOS, Android, and Windows, TISM for the Samsung devices and their fridges, their TVs, that sort of thing is in there, is different for each of them. So navigation stack was different for each of the platforms. As part of a shell that's now been kind of sorted out and done for you and abstracted away, so you don't need to think and worry about that too much. So at the top, we just set some colors, and then we have a flyout. So the flyout is as a panel that comes out from the sides and allows you to view a list menu. And then we just set the pages. And in there, we have a tab, and the tab is just the tabs at the bottom of the page. We give it a font icon, which is a little glyph that you know and love. And we say that we want that to be a hand pointing up. And then we tell it where to go when it goes to hand control view, when it goes to grip list view. And it's as simple as that. That is the navigation done for you. There's no code behind that you need to think, worry, or do. That's it. It's done. It's in version 5, which is in beta 4 or something, I think it is at the moment, and soon to be released of Xamarin Forms and Xamarin Forms Shell. This changes subtly, very slightly. You can still use this model, but it changes and makes it a lot easier as well. And then in the Bluetooth, there's the I've forgotten where it's gone now. The Bluetooth services here, and then we're just using to send a command. So you click a button, and all we do is we call in to send you our command. We pass in the string we wish to provide, and it sends it out on the ASCII, converts it to ASCII, and then sends it out and writes a characteristic out to Handy across the Bluetooth connection. So again, it's dead simple use of the Bluetooth stack. Behind the scenes, there's a little bit more going on, which I'll not go into today, but all this is on GitHub for you to go and have a look and play with if you wish. So going back, how do we get this to Kden then? Well, as a developer in the Microsoft and .NET stack, what I do is I work away on the project. I push up to GitHub as we all do in our daily lives. And then I use App Center. App Center picks up that GitHub a push, and it pulls it in and does a build. It does 2 builds for me. It does one on my dev branch and one on my master branch, now called main. It's quite an old slide actually. And the dev branch gets built. If the build succeeds, which hopefully it does, we all love it when it does. It then gets pushed out to my device and my test devices as the developer. And the master branch, anything that gets pushed to that gets pushed out to Kden and his parents, and they get a little email and they click the link, the button in the email, and it downloads the latest version. So it's not via the App Store. You still need to do the provisioning and the sign-in, etc. But App Center takes care of most of that for you as well, and it does the sign-in. So we want to add another child to this group, another family to this group. We just provision their devices within App Center. Is taken care of for you, and then they get the updates and the pushes and notifications as well. So the good thing is it's free. How awesome is that? Not only am I using Visual Studio, which is free, not only am I using App Center, which is free, GitHub, which is free. All this stack, the whole stack is completely free. You can pay for more build minutes, but you get 240 minutes free each month, and 100 devices on iOS. I can't remember, it's 250 I think on Android, but it's all there, completely free to go and use and build your mobile apps and push them out to your users. Also, you get analytics that come back the other way. You get crash analytics, you get usage analytics. You can see what devices are being used by the different people that are part of your test team. You can see which version of the software and OS they're on. Obviously, they agree to this, and the crash analytics come back. You just obviously need to make sure that you sanitize those for any personal identifiable information, etc. But I just let the crash analytics come back. I don't take anything else, and all I know is the fact that what devices they've got and what OS they're running, and they agree to that when they sign in and use the app, which I don't think is too bad at all. So drawbacks then. So we've crossed off the MyOS sensor. We got rid of that by changing it to the force sensor resistor. We crossed off the processor by moving to the Adafruit boards. We crossed off the grips because now Kden can use his own grips. And if I plug this in, and we see the fact that Kden wanted his Xbox grip. So if we bring up visor and bring it across, and I plug in Handy and bring on the app. So this is the app running. This is a slightly older version of what we've got using at the moment, and it's because we've made some changes. So we plug in, and we can see the fact that Handy should appear. Should appear. There it is. It's at the top. So we've logged into the app. Now, if we go across quickly to the Bluetooth connection, so UART control connection, you should see that this is the UART signal that's going backwards and forwards. So in the development version, for the first few seconds, it's doing this talk backwards and forwards. This is the if you're just connecting this over PuTTY or a SEAL port connection, this is what would appear on your screen, and it gives you commands like if you want to do the fist grip, you send G0. So if I send G0, it would do the fist grip. This here is locked down on Caden's phone, such that it doesn't go in there and start breaking things, because you can change some of the settings in there. We don't want to break, which is why I'm showing this development version rather than the one that's on Caden's hand. But we go back here, we can see the fact that this is the initial design. Hopefully you can see Handy. If I was to press that, you can see Handy is now going to make a fist. Push it again. Oh, and you can see Handy goes back out, and we can see the fact that we can go to a different grip. So this is the hook grip, which is carrying the shopping, and it comes back out. You can see the commands at the bottom. It's saying which commands are being sent. We go across to the oh, nearly drops Handy there. We go across. If you can hear, I'm not sure if you can hear the whining there. There's a funny story behind that. Because I've got a couple of dogs, the motors work at a frequency, and I want them to move a little bit slower so I can see the fact of what they're doing in the software. And when they're moving a lot slower, they make a high-pitched noise, which sends my dogs nuts. So I've tuned it down to something that's in our audible range, but doesn't send the dogs nuts, but allows me to move them slower. So it's, on the development one, that's what it does. In here though, you can see we've got the grip sequence. So it's fist, hook, point. The other two are turned, or the other three are turned off, and you can turn them off just by changing the heart at the top there. But maybe I want the hook to be the first in the sequence. So I can now change the sequence and make the hook the first one, and then I can save that. And then that's now the sequence that's saved down to the hands. Grip builder, you can use this to change grip. So you can see the animation step, and this is where we made that 3D array earlier. So that animation step is at the top, and then we can change and we can set some sliders to say that's where we want the fingers to do, and start building it up. And then we've also got a muscle sensor check. So once or twice a week, Caden goes in here, hits start, and he goes through a predefined sequence where he's opening, closing, and changing grip, opening, closing, changing grip, and he's trying to get those bars as high as he can on the green bars. What happens is that's all saved in the background, sends it for processing. It goes up to Azure, to an Azure function. It's put into blob storage, and at some point when we've got enough data there, we're going to get machine learning to look over that data and work out what settings need to be changed in Handy. Next time Caden connects, it will look at the Azure function, grab the new settings, and then send them down to Handy, so that we don't need to, or the parents don't need to, or the medics, etc., don't need to change the settings. It's done for him as he works on with the hands. So back to the slides, back to the cost then. So all the 3D printed parts we said was £15–16. All the boards, the controllers, and etc. there. Everything is coming in at £516. That's a complete arm. That's a complete prosthetic arm. So way cheaper than the 4.5, 6.5 for just the arm part without the hook for NHS. Way cheaper than hundreds of thousands for a prosthetic arm that's built by another company. Way cheaper than even Robotics at the moment. They're selling there. There's a lot more complex than what we're building. So you know, they've got a company to run, but this is all open source on my GitHub. You can go and download it, print it, build it, you know, and share it with somebody around the world. But it's super cheap to build one. This I'm aiming to try and get below 500. That's my target, and I'm working towards that. What's next though? Build out the Xamarin app. It's working on that. Thanks as machine learning. Go full .NET, and we started work on leggy. We started looking at prosthetic legs as well because technology is the same. Why not? But go full .NET. That's piqued your interest, isn't it? Well, if you're into IoT, you may have heard of Wilderness Labs, and this is the Wilderness Labs board. As you can see, I've got a few here. This is exactly the same form factor as the Adafruit Feather board, except that red box element at the end has got an ESP32 chip on, which does the Wi-Fi and Bluetooth. But you program this with .NET. You program this with C# in Visual Studio. All the tooling's there. The beta release 4.4, I think it is, has just come out in the last few days, which has added the Wi-Fi stack. Bluetooth isn't quite there yet. I'm talking with the team and trying to see if when they've got it, I want to put the board in the back of Handy and pull it out. Not just because I want to go full .NET, but it gives things like making changes to the app and to the code that's on Handy. It'll all be in the same language, so I can share the models that I use across them and the classes, etc. I can share that data between the app and the board, and why not do that? These boards are pretty good boards. You can see the list there. I'm not going to talk through the supported features, but you can run .NET and a Raspberry Pi, but you don't get all the things like running off a battery. You can run a Raspberry Pi off a battery, it won't last very long. It's quite a big board. Arduino, depending on what model you get, you limited Wi-Fi. Some don't have Bluetooth. You can get Bluetooth ones, so this does need a tick in there now. There was a version of .NET that run on Arduino boards. It wasn't very good. It was .NET Micro, I think it was called. But yeah, you can see here the Meta board ticks all the boxes and works. Why do I mention becoming a pilot? Why I mentioned I am a pilot, sorry, in the last few moments. My dream is, and it was hopefully going to be this year, I got a Mark III printer up there, Prusa Mark III, which I bought last year, so 2019. And does anyone remember 2019? Seems so long ago. It's been built, and the idea is going to put that in a box with some filaments, and I've got some baggies filled up with components to build 4 or 5 arms, all the springs, the screws, etc. And the idea is put it all in a box, take it with me on a trip somewhere around the world, not decided where, or find a team that is willing to entertain me. If you know anyone, please reach out and let me know. My Twitter handle's on the side there. Take it down there, go and meet with them, show them how to build these hands, and then go back over the course of a few months, because I can bid for those trips wherever they are in the world and help them build these arms out and help them change the lives of some children and young adults around the world. That's the dream. It wasn't the dream when we started this project, but it's become to a point where we can make these so cheap that why not do that? The expensive parts of the printer I'm going to donate from me and my little freelance developer company. We can donate that printer to them wherever they are in the world. So if you know anyone, please reach out and let me know. And I just want to say thanks to Caden and his family. It's been fantastic help. Caden's been brutal in his feedback, but that's brilliant, because it means that if he doesn't like it, he says so. As a teenager, sometimes grumpy, but there you go. And it's meant that we can move this project forward. Because if he just nodded and said yes, 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 that's fine, that's great, it never would move to the position it is now. That's my talk. Thank you very much. You can grab all the stuff on GitHub. If you look me up on GitHub, Cliff Agius on GitHub, you can find it all there under the name of Handy. Looking across at the questions, got one from Pete. What's on my t-shirt? Well, as a pilot, I'm not sure if you can see it, but buy airline tickets like you bought toilet roll. I think we need some passengers. Not seen many of those recently. And then Pete, what's the next project you're going to get involved with? Leggy is the next project we're working on. And the next talk I'm doing, I think, is next week. I'm giving a talk about the mobile flight sim that I built, and then there's the Azure stuff that I'm doing, Azure IOT. I'm studying from AZ 220. So I'm not sure if there's any other questions, but if not, you can find me on Twitter. I think I'm out of time anyway. Yeah, thanks for coming along, and enjoy the rest of DDD. I can't see any more questions. No, I think that's it. Thank you very much all.